All right. Hello, physical science students. I'm making a video today about energy. Um, I'm going to show you a couple of demonstrations using a hair ponytail slash rubber band, and I'm also going to share my screen with you and give you some notes. Uh-oh, I already got my hair ponytail stuck in my ring. All right, so first let's start with notes. I'm going to go ahead and share my screen with you. The first thing is I kind of wanted to make fun of slash argue with this module 1 motion energy interactive thing they have for the energy lesson, right? You're supposed to click on stuff and it tells you if it uses or doesn't use energy, right? So the stove, okay. The table doesn't use energy, but making the table, right? You have to use energy to make the table. Computer uses energy, sure. Chair, not so much. Again, you have to use energy to make the chair. TV, light. This is where I have a problem. They say plants don't use energy. Are you kidding me? Plants use the energy from the sun to make food for themselves. That's using energy, in my mind. Clearly, they're not a, biology teacher as well, so maybe they don't have a problem with that. But I do. The rug, again, making the rug uses energy. So a little problem I have with the plant, I'll let it slide because this is physics. All right, so let's go into this PowerPoint that I made. Objectives for this little mini video lesson: understand the difference between kinetic and potential energy, understand the law of conservation of energy, and compare and contrast the 3 types of systems. So first thing, what is energy? Right? Energy is not the same in physics as it is in everyday language. So you may hear people say, I have low energy, or I'm super energetic today, right? That's a different meaning than what energy means for physics. In physics, it means the ability to change or move matter. That's it. Ability to change or move matter. That kind of sounds like it could be anything, right? Examples include heat, motion, right? Pushing something, pulling something, moving it, and chemical reactions, right? Chemical reactions have energy. So kinetic versus potential. Oh yeah, I was going to make this colorful and I forgot, so I'll do it right now while I'm talking about it. So kinetic energy is also known as moving energy, right? That's energy that's in motion, that's happening, that's moving. Potential energy is possible energy, also known as stored energy. So what does that mean, right? Well, we're going to talk about a rubber band. Remember to pause at any time in order to take notes. So really quick, I made myself bigger. Woo! I hope it's recording this too. I'm assuming it is. So if you think about a rubber band, right? If it's just sitting there normally, whatever. If you stretch the rubber band back, like you're going to fling it in your sibling's face, you are creating potential energy here. It's possible. It's stored. It's ready. As soon as you let go, oops, thought it was going to fly away and it didn't. As soon as you let go, the rubber band, in theory, would fly, right? And that moving portion would be kinetic. So potential, kinetic. Potential, kinetic. Kinetic is the moving, potential is the possible stored energy. Now, here's an interesting thing. Potential energy also happens just from an object having height, right? So here's my phone. Yes, I have a shell phone case. I'm obsessed with big, oversized phone cases. Okay, so if I hold my phone really high up, right, there's a lot of potential energy here. If I let go, it's going to fall pretty far. Whereas if it's already on the ground, there's way less potential energy here, right? There's nothing really going to happen. It's already down. So we'll talk about what that kind of energy is specifically called. But potential energy can be just from an object being high up. Okay? So, kinetic or potential, right? So here, this rock has potential energy. It is high up on this cliff. If it happened to fall, it would probably kill that Tarzan lady or man. Not sure. Running Man feet with a Starbucks cup. I also like GIFs a lot, so I had to put one in. That's kinetic energy, right? This energy is moving. The fingers are moving. So potential, the rock has potential to fall. There's a possible energy here. Kinetic, moving energy. Forms of energy, right? In the lesson, they have flashcards for these for you. I wrote them out here. Thermal energy is heat energy, right? Think about a thermos, right? Usually you put your coffee in a thermos to keep it warm because it's trapping that heat energy. Elastic energy, think of the rubber band again, is a potential energy by stretching out an elastic or a spring. Radiant energy comes from electromagnetic waves radiating, right? So think about infrared. If you ever play any of those video games where you see the heat that humans or animals are letting off, and that's how you track them down, that's infrared, right? That's a type of electromagnetic wave. Sunlight, the sunlight has electromagnetic waves in it. UV rays, also from the sun, right? Those are what give you a sunburn. That is a form of kinetic energy. Those waves are moving. Mechanical energy is basically just any kind of movement happening because of machinery or because of the way something is designed or organized, right? It's another kind of kinetic energy. Nuclear energy is the potential energy of an atom. Inside each atom, there is stored energy in the nucleus. It has potential. Gravitational, this is what I was talking about with the phone, right? This is based on how high up an object is. So the phone here has more potential energy than my hand, right? If I flip them, my hand has more potential energy than the phone. Just has to do with height. Chemical is a potential energy stored in bonds, right? So when elements form molecules together, like for example, a water molecule, the bonds in that molecule store energy. And that's actually how your body gets energy from food, is we break apart molecules, we take that energy, or we build molecules to store energy, right? So for example, fat is a ton of stored energy. That's all it is. It's a bunch of bonds. All right, so hopefully you paused and wrote all that down. Law of the conservation of energy. Energy cannot be created or destroyed. There's a set amount of energy on the earth, that's it. Can't be created, can't be destroyed. It can only be transferred between the forms. So we can go between potential, kinetic, right? We can go back to all these forms. We can go between all these different kinds. Thermal can become elastic, which can become mechanical, which can become nuclear, which can become gravitational, right? Energy is constantly switching in between all of these forms, but it's not being created or destroyed, right? This is a law. That means we have proven this in science. You cannot argue with this. You can try to come up with as many reasons or ways that you think this is not happening. I guarantee I will be able to tell you how energy has been transferred in that situation. Types of systems. I stole this from a website because it's good. So there are 3 types of systems. I recommend printing this out if you can. So taking a screenshot, copying, pasting, or write it in your notebook. Open systems can exchange both matter and energy with an outside system. They're portions of larger systems, and they're in intimate contact with the larger system. Your body is an open system, right? You're constantly interacting with the world. You're getting energy from food, you're releasing energy, you're releasing waste, right? Right now you're releasing heat energy through your skin, right? So we're constantly interacting with a larger system, which is essentially the world. Closed systems exchange energy, but not matter, right? So they're typically portions of a larger system. They're not in complete contact, right? So the Earth is essentially a closed system. We get energy from the sun, but we don't really exchange matter with space, right? Every once in a while, an asteroid will come in, a meteor will come in, right? But we're not constantly exchanging actual objects with space. But energy, we are. We're getting energy from the sun. The Earth releases its own energy, right? We also have gravitational energy, right? Earth is actually in an orbit, right? There's all sorts of other things interacting there. Closed systems, you might also want to think about any kind of machine, right? Machines usually don't exchange matter with outside objects necessarily, but they can exchange energy. They release heat, maybe they take energy like electricity, right? So you might even think of your phone as a closed system. You take energy from an outlet and your phone produces heat energy, right? It produces infrared energy that you can't even see. But it's not exchanging matter, right? A piece of your phone is not coming off necessarily. And then isolated systems exchange and don't exchange energy or matter, right? They are completely closed off. They're isolated. So this one is kind of hard because it's pretty hard to not exchange any energy or matter with anything, right? They argue here that the universe is an isolated system, right? That's assuming that the universe is not interacting with anything else in any other kind of way. And we can't really prove that, right? We usually think of a thermos as an isolated system, even though it's not perfect, right? A thermos is not 100% holding in heat and all types of energy. It's more a closed system, but we can consider it an isolated system if we say that it's not exchanging energy or matter with an outside system. Okay, so this is kind of confusing. Really, the only thing that you're going to want to use this for is when you're doing the energy assignment for this particular lesson. They ask you questions about these, so just read it very carefully. Think about if matter or substance is being exchanged, and then think about if energy is being exchanged. The biggest energy exchange is heat, right? Heat is always escaping at all times. So that's the best way to think about whether energy is being exchanged. Just think about heat. All right, so this has been a mini lesson about energy. Hopefully that has helped you understand a little bit better how energy works, and you'll be able to complete your energy assignment. And I think the next video I'm going to make is going to be on sound. Actually found tuning forks so I can play notes and talk about sound waves and do some cool stuff with that. All right, so please email me or text or call me if you have any questions, especially about the energy assignment. See you guys soon.